So kicking off, we'll come to some of the questions that were in the chat earlier a little bit later, but I want to kick off, Jana, really with your perspective, if that's okay. So what was it that inspired you to get involved with doing robotics in your school in that way?
So I always enjoyed watching Robot Wars on TV as a kid. I watched it quite a lot. It was a good program. And I was lucky enough to actually go to some championships and see Ed compete and go behind the scenes and see all the robots being built, which I found fascinating. And at school, my favourite subject was actually technology. So not the usual technology with all the computers and everything, more resistant materials, so woodwork and metalwork and that kind of stuff. So I was always more interested in the exterior and more of the armour of the robot than actually the internal stuff. And I decided to go and talk to my tech teacher, my head of tech, and my head of the school, and suggest that we do a Robot Wars. And they jumped on the opportunity, and I ended up running a competition and also running a club once a week with everyone could come from year 7 to year 13, where they could just build robots and have a bit of a laugh. And it started off with, I think the kids mainly use kind of toy car carcasses and that kind of thing, and just kind of took them apart. And then as parents got involved, as always, it got a bit more competitive, and the parents started to bring stuff in and things like that, which was quite interesting because the robots went from these tiny things to slightly bigger with actual weapons that could move and things like, which was great to see. And then so it was just an in-school competition to start off with, so anyone could join. And then I decided to put advertisements on Facebook and email all the local head teachers and get other schools involved. So it eventually became actually a quite big thing the second year compared to the first year that I ran it. That was pretty much the whole competition summed up.
I would just add to those who are listening to the panel, if you do have any questions for any of our panelists, please do pop them in the chat and we'll come to them as we go along. So maybe Ed, will come to you next. So that's Jana's perspective on getting the robot competition within school set up. Can we hear a bit about it from your side?
Yeah, I mean, we've sort of been serial creators of stuff in schools as a team. You know, for us, it was always something we wanted to give back. You know, we reached that point where we'd won a world championship, and you know, I've jokingly always said the only way from there is down. And so it was, you know, what other direction can we take it? And yeah, we were lucky. We were a well funded, well sponsored team, and we just kind of felt like we had a moral duty to find a way of taking this stuff into schools. Initially, it was through a program that the BBC created called Expert Roboteers, where the BBC would work with teams they'd had on the show actually and connect them with schools. So at one point there were hundreds of teams taking part in Robot Wars, and local schools could get connected via the BBC to a team near them, and that took us all over the country. And then since then we've sort of been refining. You know, what works well, learning from the stuff that we did with Jana's school. You know, we've done some stuff with universities as well. And yeah, we've now got a format that works well, or a structure that works well, and yeah, that's pretty much what we've been focusing on. And you know, again, more than welcome to connect me with anyone after the Zoom, and I can fill people in on what was involved in that.
I think you might have a few people taking you up on that one, Ed. Grant, coming to you. Ed sort of mentioned that you were an expert engineer. I don't know if you were there. He was saying nice things about you behind your back.
I heard it.
He went into sort of making and creating. Could you tell us a little bit about your story and how you ended up where you are now?
Yeah, so it's actually my brother and I. My brother's a couple of years older than me. We were sort of Jana's age back in school, just watching Robot Wars on TV, watching those sort of programs, and you didn't have social media back then, and it was sort of trying to get your hands into something and just going out with your friends and having fun. And we started making robots of sorts with our remote control cars, strapping knives, drills, all sorts of that sort of things on top. And
not advised to be tried at home.
Yeah, health and safety rather.
Health and safety's changed in the days.
Imagining every teacher on this call sort of giving children knives.
Yeah, well, unfortunately, we had to build an arena. We had a few things fly off and hit some cars in the car park, but yeah, it was getting together with friends, getting these remote control cars with polystyrene Coke can armor with these knives and spatulas and drills strapped on them, and going around each other's houses and battling them in the gardens and things. And we did that in school, and our sort of, it's a bit of a shame really. Our technology teachers at the time weren't all that helpful. It was like, can you help us sort of make this properly? Can we build a steel frame for this, or can we do something a bit more? And it was always, oh, you won't be able to compete on Robot Wars for many years. You won't be able to do this yet. Let's just sort of stick to the basics. And so we sort of just did it outside of school. And fortunately, our father, he runs an engineering firm here in Birmingham, and so we had the resources there, and someone that was able to sort of teach us the basics to actually get to learn to weld, to learn to bolt things together properly, and come up through the proper processes. And yeah, it sort of grew and grew through watching people like Ed and some of our real good friends now competing on Robot Wars back in the day. That sort of just gave us that inspiration to want to have fun and do something. It wasn't at all about learning. It wasn't, how can we calculate this? How can we design this? It was all about having fun with our friends and just trying to build the best thing we could at the time. And that sort of just moved on until the year after I left school. We actually we went into my school teaching STEM subjects through building these robot kits, and our company was set up then many years ago to where we are now, building all sorts of wacky robotics and engineering projects for TV shows, PR campaigns, and now actually running Robot Wars for the BBC.
You mentioned their robot kits, and we had a question earlier that leads really nicely onto, which was asking about, Ed, you mentioned about base kits, about sort of, I guess it's being able to create something that works fairly simply. What would you, and maybe let's start with Grant, if that's okay, and then we can move through to Ed and Jana. It'd be great to get your take on this as well. What do you think is the sort of base kit essential for getting started with robotics?
So there's a few people out there, including Ed, ourselves, and a few others, that provide and work with schools to provide a very sort of basic kit that can at least get you started. And the idea is that you can give the team something reliable that, you know, if they follow the instructions, they can put together and it will work. It'll be a bit boring, but it will work. And that's sort of the basic level that you really want to get into a school. Something that they're not going to spend their whole time working out, why doesn't this work? Why doesn't that work? They can at least get something together quickly to get their imagination flowing. If they spend too much time trying to actually get the thing working in the first place, they'll get a bit bored of it. You need to get some excitement in there. And just like Ed, when I was in school, you start doing pure maths, or you start sort of just reading from instructions, and it's really not engaging. You need to get engaged very early on with these things. So I think the key thing in any kind of kit or educational sort of tool is get them started quickly and get them engaged. And then from there, the team building and all the other things that come with it come from there, where they start wondering, oh, we've got this working, we can drive this thing around in the classroom. Now, how can we smash this? Now, how can we get under that person? Now, how can we make it look cool? And it's that next stage where they really start expanding from a working base that it really gets exciting for them. But I think the key thing is, it doesn't matter what the kit is, where it comes from, how much it costs or anything. It's all about, once they've got it, make sure they can get to that first stage fairly quickly and easily, and just get them engaged.
I think that's really good advice. It's what, to link with the session that we just did with the microbit, one of the things that I always say about it, it's got very low floor and a very high ceiling, and that feels like what you want in this. You want that first level of engagement to be kind of almost instant, but then the growth from there to be as wide as people want, really.
Exactly. And you'll see, it's just watching the teams on Robot Wars, the nice thing is everybody's got something very unique and different, and by giving them a fairly plain but reliable platform to get started with, you see all this sort of the emotions of people come out. So you can have, like you say, your unicorn robot, or something on flames with a big flailing axe, and everyone puts their own personality into them. But it's important to just give everyone a good base to get engaged with, and then put their own personality onto it.
Ed, I imagine you would echo those sentiments.
Yeah, we learned really quickly, and yeah, Jana went through this frustration that if you make the entry level too hard, people switch off really quickly. No one wants to lose the fight because their robot gets interference from the controller that they borrowed from their radio controlled car, or they lose their fight because they've got a set of really cheap batteries that run out of charge halfway through. And what we realized was that actually we weren't asking kids to innovate on how you build the electronics or how you do the control. What we were asking them to innovate on was all the stuff that would happen on top of that standard platform. So there was no problem at that point with saying, look, here's a kit that you can get going with. So the first day in your computer club, or your robots club, you should all be able to get something that will drive around and move and bash into each other. And that sets the spark going. And where I've seen these fail is where people try and make it too complicated, or they don't understand what they should be getting the children to focus on. For me, the experience of building these machines is about community, about cooperation, about getting through that cycle of learning fast. Oh, and by the way, you're going to learn a whole bunch of stuff about base engineering and robotic stuff by osmosis without even trying. Where I find people, and I think it might be an educator's thing, is that they're trying to align to a particular bit of a curriculum, perhaps. And so their goal is, I want to do something about electronics. Let's use this to do an electronics project. When actually the electronics bit's going to happen anyway. You don't have to focus on that. If you focus on all the other stuff, it will drive the other learning that you're looking to get.
Project-based learning indeed, Jenny.
It's even got a fancy word.
There you go. Jana, does that echo kind of your experience of getting started and then building those?
I think it completely echoes. I found with the children that, well, children can get bored quite easily. When things don't work, they get a bit fed up, and sometimes they just storm out the classroom and think, I don't really want to do this anymore. So giving them a base, which quite a lot of the time in my situation was kind of a toy car or something like that already works, and then they take it apart, and through taking it apart they kind of learn stuff along the way, as Ed said, with osmosis. But the main part that excited them, I'd say, was actually the designing of it. So they did loads of drawings, things like that. It'd all get in teams, and they get very competitive about it and say, my robot's going to be better than yours, and it's going to have a swinging arm. And it was actually more about all the little elements and things of how it's going to attack each other than necessarily just the big carcass that was the starting point.
I think that's another really interesting point there, Jana, the idea of taking something apart to learn about it, reverse engineering.
Yeah, I think it was a lot easier than putting it together.
You hear that a lot from people who work in computing, saying, what was your first experience of this? Well, I took my computer and I hacked it apart, tried to put it back together again. So kind of on that note, we've had a question in the chat there, Jana, kind of aimed at you about support from the school. So I know you sort of got support from Team Storm and what they were bringing in. But aside from that, was it very student-led, or did the teachers get really into it as well?
I'd say so. There was only one teacher really involved with it. The head teacher was happy to help with all the kind of event management and that side of it, but obviously she didn't really know too much about robotics, so it wasn't really her field of expertise. But my head of technology was amazing, to be honest. He helped with everything. He was there every week with the club. He was very involved. He even built his own robot and competed with that as well, which was fun for the kids because they saw their teacher compete. And I mean, yes, it was partially student-led, and I think also parent-led, because when some kids would go home to parents who had technological backgrounds, they would go, wow, that sounds amazing, and like a nice thing for them to do with their child on the weekend or something like that. So we even had some teams turn up that weren't at the club necessarily, but had heard about it. So built a robot with their mum or their dad or something and just emailed me and said, I've got this, can I bring it along? So I think mainly the teacher, he helped a lot, but then also the parents.
Just to jump in there, though, Jana makes a really good point when she said that one of the teachers built the robot as well. Building these machines from a base set of parts is an amazingly level playing field. And we see this on the TV show, right? You can end up with a team with little expertise taking on a team with incredible expertise, but it's all about what you manage to build. It's all about what you manage to put in the arena. So, you know, just because a teacher's built a robot doesn't actually mean it's any good. It certainly doesn't mean it's going to win. And yeah, that's one of the nice things about leveling out the playing field, is that if you remove the basic failure modes by giving people a really simple way of approaching it, it's all about what you can come up with on top. And it turns out kids are great at that because they're free thinkers. The really funny thing is that when we first got into robots, actually we found the worst people to work with to help us build what we wanted to build were engineers and engineering companies, because they had set understood ways of solving engineering problems. So we would come in and we would say, look, we want to build this, but it needs to be built like that. And then engineering company would go, well, that's not how you would solve that problem in engineering. We'd solve it like this. And we'd be like, yeah, we don't think that's going to work. So yeah, so it's a great level playing field for all age groups by pulling it together.
Grant, I saw you smiling at that. From an engineering company, I guess, or creative engineering, how would you describe it? What would
Grant's the exception.
Well, so sorry, I was in a bit of two things at the moment. I've got a big project going out the door, and I've just had a phone call to say all the 3D prints a company down the road are helping for, the power's gone off, so we need to knock some more up. But not to worry. But in the meantime, it's a really interesting thing. Like I say, you start from a base kit, and you see everybody's personality come out in them. And I think Ed's one of the people that people on Robot Wars have always seen as being this very wealthy guy building expensive machines and all this stuff, because he's had the backing of being able to get sponsorship from companies like BT and things like that to do what he needs. But at the end of the day, the thing that's really shown through is you have robots like Nuts that's built on a £1,500 budget in the shed, taking on some of the most expensive machines in the competition, purely through their really unique and interesting ways of doing things. And this kind of project in schools is one of the best ways where you don't have unlimited budgets, you don't have unlimited resources, and it's all about how you can problem solve and how you can work together as a team to come up with something incredibly unique that no one else has done before. And that's where sort of these personalities really start to shine through. And again, that's where I think the enjoyment comes in for students, because they're engaged in problem solving and how they can outdo somebody else, and not thinking about, oh, well, how do we calculate this to go a bit quicker, or how do we calculate this to run for longer? They almost don't think about that. That just happens along the way. And I think that's one of the most impressive things with this sort of fighting robots projects, that it's just the principle's so simple, but the ideas that can come out of it are immense.
Grant makes a really good point there. When he was talking about the perception that Team Storm were this well-funded team, lots of sponsors. And actually, what was happening was we were playing to our strengths. So, you know, I'm not an engineer. That's not my DNA, right? That's me out of my comfort zone. My comfort zone is selling an idea to someone, convincing a company that they want to help me do something. And so for me, ironically, I would have preferred to have not had the skill of persuading a sponsor to help me. And I would have rather have had the skill that Grant carries, which is the ability to stand and use a machine and the ability to build his own parts himself. Because what people don't see is the sponsorship angle is great, but now I've got a supplier management nightmare. Now I have to deal with suppliers and project management, when actually it would be much easier if I had the skills to build it myself. And so that's what you see come out with the children. They will naturally start to play to their strengths. They work out the value that they bring to the team. They work out the bit that they can do well. And yeah, for me, it happened to be that we ran a tight ship. We were capable of getting sponsorship and expertise on board, and use that to our strengths.
I think that loops through actually that idea of sort of playing to strengths and finding those roles that people can play within the team that really showcase them. To one of the questions that we had earlier, what do you do when the passion starts fading? And we've all seen this in projects that we've done with children and adults alike, that everyone's very enthusiastic about it right at the beginning, and then that can dwindle and fade. So how do you keep young people motivated through these projects?
That's a good question. And I say that in a reflective way, because we haven't had that problem. In fact, so much we haven't had that problem that at Jana's school, what they did, and Jana probably talked to this, was they actually took the people that were involved in last year's event, became the people that helped organize next year's event. And so you rolled that enthusiasm and learning over to the next year. And I think that's a way that you keep it alive and fresh, is by you keep engagement. You have new children come in who feed off the excitement of seeing last year's group that went through it. Maybe maybe they came to the assembly where this group of older children, or perhaps I'm just using that as a generic statement, right? The group of older children talked about what they wanted to do and what they were doing with robots, and then the younger children aspire to do that when they go into the next year group. So I think the trick is to build it as something within the school, something the school can get behind and be proud of, as opposed to perhaps just see it as a little point in time project.
Yeah, I think to add to that as well is that we're talking about fighting robots and what we've done in schools, and inherently fighting robots is a perfect scenario where you don't have a sheet of paper listed with points you need to achieve. There's one end goal with a million ways of achieving it, and there's never a final point. So like Ed will say, he won the world championships, and that's not finished. That robot's not complete. Everyone's still progressing. You need to keep on pushing. And I think for me, the engagement is always there because there's always something interesting to try and do. There's always improvements to make.
It's never finished.
But when you're doing a project where, and we get it all the time with work, they've just got a number of things on a list to tick off, and you're just going down a set criteria, the engagement does wane. If you're programming something and you've just got to learn, or an equation, and you've just got to learn that equation for a test or whatever, if you're not using your own imagination and your own knowledge and interest to achieve what you're trying to do, that engagement does just slowly disappear. And I think fighting robots isn't the only option, but it's a good one where it's a very simple end goal and a very simple starting platform with a million ways to achieve it. And it just gives the flexibility to the students to do things how they want and how they feels best, instead of just being told, do this, do that. And I think that's the key to it, really.
Jana, it'd be great to get your take on that, both in terms of that process of creation, but also in terms of that keeping, I think, Ed, did you talk about like institutional memory, keeping that kind of...
Yeah. So the idea of rolling the program forward, there was almost like a ceremonial handoff at the end of the event. And these are next year's kids. They're going to be taking over some of the stewardship, some of the organisation, and you could see the excitement that I've got the baton. This is my baton now, and I'm gonna get to do something with it.
I didn't really find that the passion died out. I know I can see it's obviously the circumstance for some people, but for my club, the attendance, it was the same every week. Everyone, you could tell they genuinely wanted to be there and they really enjoyed it. So, and unless they were ill or something, they were always there without a doubt every week. And I mean, the event that I ran, I don't think it just caused more people to get excited about it. The amount of children who came up to me at the end and said, well, because I did it in my school theatre, and I said to all the kids, I sent emails out, did assemblies and said, come along, watch, we're doing this big competition at lunchtime, it's free for everyone to come in and just have a look. And so many people came up to me, and I had floods of emails being, next year, can I do it? Oh, that looks great, wow, that was so amazing. Because I think people didn't anticipate how much fun it was going to be.
I mean, we would have run the event again, obviously in 2020, but things happened. But we were already going into thinking about the 2020 event, thinking how are we going to continue to grow this, because it had gone beyond a couple of schools. We had we could have probably had 15 schools all wanting to take part in the 2020 event with multiple teams, and so we were already trying to think. Actually, the problem wasn't getting people engaged. The problem was how are we going to meet demand.
That's a lovely problem to have, I think. I'm going to keep encouraging people. Please keep popping your questions into the chat. We've still got some time for this panel. I'm going to keep chatting away, but we want to make sure that we answer your questions. So if you do have any, please do put them in the chat. I'm going to ask Jana a question now. Jana, thinking about kind of getting really into that robotics and organizing those events, kind of having those responsibilities, To what extent do you think that that's impacted the choices you've made since, in terms of your university choices, in terms of what you want to study, and in terms of what you're thinking about doing beyond that time at university?
I think it kind of helped me realise the importance of children feeling like they can excel. Certain children had never felt like they found a skill they were passionate about. And this enabled them to have a community where they could explore these skills. I mean, as I said before, they genuinely enjoy coming. And I decided to study education with psychology because I aspired to help people find a place for themselves on the national curriculum, because I feel it at the moment it doesn't fit every child's needs, and that's no one's fault, it's just the way it is. And from my personal experience, I would like to see much more technology on the national curriculum. For example, at my school, I wasn't offered A-level technology, and I think if that had been an option, because I loved it at GCSE, I definitely would have taken it, and it would have completely changed my career choice, I think, and what I'm doing now.
I think I can sense every teacher in the country nodding at what you have to say about that idea of sort of education not being a one-size-fits-all, and something like this being an opportunity. That's great. We've got a couple of questions there in the chat. Jenny's asked if there's any good base kits out there that people can get. Any Ed Grant, any suggestions of where people could start having a look?
Yeah, I think a lot depends on what it is you want a base kit for. I mean, the unicorn was the stuff that Caitlin was talking about. Base kits for Key Stage 5 and A levels. I mean, you know, we built the base kits that we took into the schools for the specific robotics challenge. You know, we never considered the idea of taking those out to a wider market. Actually, I don't know if Grant has got any specific area that he could point people to for some base kits. The unicorn thing, Caitlin, that was the little thing that you built?
It was, yeah. I'm just going to quickly answer Sarah's question, because I know you have to leave, Sarah. Yes is the answer to your question. I can put you in touch with definitely Ed, and I'll chat to Jana and Grant as well. But this is the beginning of a conversation. So do keep in touch. So yes, the robot base kit was bought actually from a website, which name I completely forgot, but from someone that I met at BET. For those of you who've been or know about BET, it's a big technology education kind of trade show, usually run at the Excel, obviously not this year because it's a hospital. At the CLC, we've been a part of that. We've sort of done talks and training at BET, so I'm there every year, checking out everything there is to see, and met a woman who made robot unicorns. And I was absolutely sort of enthralled by it. Obviously, on the day, had a little play, and found out that she sold them on her website. Now, in the end, I think she stopped doing so because she was a one woman show, and the robot unicorns got a bit too popular, and she was having to sort of 3D print every unicorn horn and print off every kit. But the basics of it, I sort of managed to do a recreated version. So not with the broadcasting, but I used to run a session for year 5, year 6 students using actually crumble controllers rather than microbits, in part because I could get the motors really easily. But literally just using a plastic takeaway container with a crumble controller hooked up to 2 motors with some Lego wheels stuck in the front of it. And you can make a little buggy that moves, that you can program and that moves using literally just those components. And then from there, it's kind of the decorating and the what do you want it to represent and achieve. So I'm afraid that's not an enormously helpful answer in terms of where you can buy that kit from, but you can kind of create them yourselves with things that are really sort of cheap and easily available, would be my take.
Yeah, I mean, we could certainly. People asking for follow up. I've got no issues with spending some time helping people identify what could be a good kit. Something we really learned is that a good kit needs to be repeatable and easy to replace. And so one of the things that we focused on actually was, you know, how do we, rather than coming up with a set kit, can we come up with a set bill of materials that you can go and buy from a variety of sources? You know, all schools have got different ways they procure things, different ways they buy things. So yeah, so whilst I can't point you to a website that says click here for perfect key stage whatever kit, I certainly don't mind having a conversation with anyone around trying to work out what might go into such a kit that you can get from the open market as some component parts.
Yeah, so from our side of things, at Robo Challenge, we've created some slightly larger than Ed's, again, 12 kilo kits about this sort of size, that we've actually, last year we ran the Young Engineer of the Year Awards in Stoke, of around 30 schools, I believe it was. And that went down really well. But the kits that we tend to produce are on the slightly larger, slightly more expensive end of the range, where the schools and a really good company called KMF actually sponsored all the schools this equipment. But if you are looking for something specific like that, we are looking at trying to roll this out on a bigger scale next year now, and just looking at ways to sort of try and bring the cost down to be a bit more affordable. I understand budgets now in schools are certainly a lot tighter than they used to be 10 years ago. So yeah, that's our key thing now, really, is trying to get something like this a lot more affordable.
I think that's such an important thing to sort of make note of and to recognize, is that schools' budgets are very tight, and also that sort of schools' timings and curriculum are constrained in that way. But that I think what we're talking about here, in a way, and jump in if I'm sort of putting words in your mouth, but is not about not hitting the curriculum points, but thinking about them in a slightly different way. So not in terms of the teacher's paperwork, you're going to have to tick off what you're hitting with the curriculum, we know that. But in terms of kind of the presentation of it and the way of pupil engagement, that it's sort of making those curriculum objectives maybe a little more incidental, and making the kind of lesson objective slightly separated from the curriculum objective, perhaps. Does that sound like what we're discussing, maybe, Ed?
I never thought of it in that context, but yeah, I mean, you know, we've never tried to around how the kids should approach the project. Back to when I was talking about how we built Storm 2, right? Simple goal for us was win, deconstruct win into what's required to win. We've tried to encourage the kids very much to do that, as opposed to the purpose of doing this is that you're going to learn about this and this and this, you're going to have a better understanding of this and this, and at the end of it we'll do a review where we confirm that you have indeed learned this and this and this, and you now understand this and this. You know, what we find that we've created, and maybe this is hard to measure in terms of a curriculum checklist, but we've created people like Jana who have gone off with a passion for something. We've created people who are excited when they start doing this stuff. We've armed people with an experience of working in a team in a really high pressure environment. Yes, doing work at school is tough, but when you've got 30 minutes to fix the robot you've just broken before you go back on stage to perform in front of 150 people, your friends, your peers, and other families from the school, and you have to solve the problem, because if you don't solve the problem, then you're out of the competition. That's what I think is the legacy that we've really left children with. Yes, they've got an excitement about engineering. Yes, they understand a bit more about some of the robotics and electronics. But I personally think that it's all of that peripheral stuff that they get as part of the experience that's the real takeaway. It doesn't feel like learning.
Yeah, I think for all intents and purposes, that's certainly what we normally aim to go in for. But obviously, we do understand that there is a very big checklist that goes along with every project like this that does need signing off. We've been doing this now for around 14, 15 years in schools. And every time we do it, we have to sort of tweak things to a slightly different curriculum or so. But fundamentally, the main thing doesn't have to change. You just make sure there's an end goal, and for the child to get there, it almost accidentally ticks off 4 or 5 of those points along the way. They have to go through those. But I think it's less about pushing those points on the children as it is to find an end goal for them to get to it without them really knowing.
It's almost impossible for them not to tick it off in a way.
Exactly.
That's great. So we've got about 5 more minutes of the panel remaining. So as we said, if anyone's got any more questions, please do pop them in the chat. We want to make sure that we're answering those. But I think I'm going to go round the panelists at this point. You're all going to look terrified, and ask you all kind of for what if the teachers who've come here today, the educators who've come here today, are going to take one thing away from what you've had to say in terms of doing these kinds of projects in school. What would you like that one thing to be? I'm going to start with Grant because I've got you on the screen, so I'll put you on the spot.
Okay, so I think the main thing, because it's what applied to me when I was in school, is do not give me a sheet of paper with a handful of things I need to tick off. Just make sure I was engaged in whatever I was doing, whether it's a maths problem, assign it to how fast I can get my go-kart to go, or anything like that, but do it in a way that I feel like I'm trying to reach an end goal when I'm working it out. As soon as I see an equation on a piece of paper and have to just calculate that at the end, my mind just switches off. And even to this day, that's something that I still I don't struggle with because I found a way to work around it. But I always try and make sure that whatever I'm doing is engaging. I'm not thinking about how I get there. I'm just thinking about the problem I need to achieve. And I think that's ultimately the biggest goal here. Just keep children engaged and keep them engaged from an early stage as well. As I said, if you're going to get a kit in of electronics or robotics or anything like that, make sure that as soon as they get it, they can get to a stage where they're enjoying themselves early on. The quicker they enjoy themselves, the longer they'll stay engaged for.
Excellent. And Ed?
I was going to say something really similar. The focus for the stuff that we've done has been around making it real. The number of kids who have drawn connections between the physics lesson they had in the morning and the stuff that they're doing in the afternoon without any need for us to lay a trail of breadcrumbs, for me is probably one of the great takeaways. I often said that it was only once I started building robots that I started using half of the stuff that I was learning when I was at school doing physics, mechanics, engineering, design, and CAD. Because I'd never found a practical outlet for it. I'd never found a practical purpose for it. It made sense in the lesson. I kind of got it, but it was all a bit academic. I get different people learn in different ways. For me, that was the way that I found learning really worked. But I find it hard to think that importance of making the learning real and relevant, and clearly understanding, what does that equation look like? What does that mean? Where does that actually help someone in real life? Is really powerful.
And Yana?
I think the importance of children learning hands-on skills. I mean, most things for me anyway, you're assessed by written assessments and that's it. There aren't many practical exams out there. So teaching these children vital skills from a young age of things such as engineering is really key, because a lot of things you don't learn that unless you go to college or you learn it at university for a degree. So it's just essential at that age as well. I mean, you should be teaching them how to build things and think outside the box and be creative. And I think that other schools would benefit from doing something similar, such as Robot Wars that I did, because it created a great sense of community. I mean, all the children helped each other out. Yes, they were competitive, but if they didn't win, they weren't too bothered. And if their friend's robot got broken, everyone jumped in to try and help. It was just so lovely to see everyone work together like that.
Yeah, I think just to add something on the end of that sort of hit a point is, obviously myself and my brother run our company, and we also help my father with his manufacturing company, and we have a real issue at the moment in hiring people to do the kind of work we want, and a lot of that is because they just don't have hands-on experience. And it's all well and good getting top grades and A in maths and English and physics, but unless you have that hands-on experience to tie it all together, it's very difficult to put that into a job and make it work. And so we don't look for engineering degrees or anything like this. We look for experience. And if you can show us you've built a fighting robot and you can do it to a good standard, we know you've covered all the bases you need to, including teamwork, to hands-on, to being able to just dedicate yourself to something. That all comes through in one project, and we hire a lot of people purely from that.
And that comes back to what I was talking about, right? When I said that, one of my concerns as I went through university was that I was going to come out unhireable and with a load of academic skills, none of which were actually applicable to the real world. And back to the point that I made earlier, make it real. That's the thing that really seems to connect.